let's study about a new topic called pressure. We've already studied about force, right? What is force? Push or pull. In short, push or pull is force. The strength with which we are pushing something or pulling something is called force, right? Just to quickly revise the concept of force, what does it do? Very first thing that it does is it changes a stationary object. It changes its position of rest to a position of motion, right? The second thing that force does is it changes the direction of a moving object, right? And the third thing which it does is it changes the shape of an object. If you press something, remember we did it with the clay, we press it, so what happens? The shape of the clay changes. So these are few things which we have learned about force. Now, let's study about a new concept called pressure, which is very closely related to force. Now, let's take a bottle, okay? If I hold this bottle like this, it is a little difficult to hold it. I feel heavy, okay? Now, if I hold this bottle like this, I'm very easily holding it. I don't have the fear that it will fall down, okay? So think about it, children. Why is it happening? It's happening because when I am holding it like this, a very small area of the bottle is in contact with my hand, okay? So the force that this bottle is putting on my hand is on a very small area. Fine. Now when I put it like this, the area that is touching my hand is more than that it was touching when I was holding it straight. That is why the force that this bottle is putting on my hand is on a greater surface area. So the force is same because the bottle's weight is same, right? So here comes the concept of force. The force that is put on each unit area, okay, is called the pressure. That means force per unit area that is exerted by anything in the world is known as the pressure which is applied by that object. Now children, let's conduct another experiment, okay? This is a box, right? The surface area which is here of this face of this box is definitely lesser than the surface area of this face, correct? Let's see how deep does it go. If I put it like this tray has sand, not sand, salt. You can also take sand instead of salt. If I am keeping this box like this and then picking it up, let's see. Does it make any indentation or any mark on it, or does it go down? Not much, right? It's just about a little bit of indentation on the sand. Now, let's put it like this. The same box, same weight, it goes a little bit more inside than what it went when I kept it like this, right? So this is because, see, this much inside it went. That means that the pressure, that the force that this box was putting on that area, the smaller area, was more. We felt it to be more. The force is same. But what is happening? It is being put on a very smaller area. But when we put it like this, the same force is exerted on a huge area. So, when the area increases, the pressure or the force per unit area which is being applied is distributed. So, it is less. So the pressure here is less, whereas the pressure here is more, and that is why the mark is deeper. Got it? Now, let's understand with this concept, how do we calculate pressure? Very simple. Force per unit area is pressure. So the force which on unit area is applied is called pressure. So P is equal to F upon A, right? Just understand. P is equal to force per unit area. So that's F upon A. Now, let's take some more examples, okay? We must have seen knives in our hands, in our kitchen, right? Our mamas have a lot of knives, right? Few knives are blunt, few knives are very sharp. Now, what makes it blunt or sharp? Let's understand. The blunt knife has a little bit extra surface area which touches a particular object that we are cutting. And that is why the force that we put on this knife is distributed on little bit extra area. Okay? And that is why we are not able to cut it immediately. So we call that this knife is blunt. But actually, what is the reason, children? That the surface area which touches the vegetable or the fruit or whatever we have to cut is a little extra than what a sharp, so-called sharp knife has. Sharp knife, when it touches, the area that it is touching is very less, and that is why the force is more on that area. That is why the pressure that is exerted is more, and we can cut the fruit or vegetable very, very easily. Just notice all these small things in your home and you will understand the concepts of science really well. Now let's conduct few more small experiments which is based on another concept called atmospheric pressure. Now this pressure is exerted by everything, okay? The air around us is also putting some pressure on our body, on anything in the world, okay? Now let's take a ball, a ping pong ball. See, I am putting this is a funnel which I have created with a paper. I'm putting this ball inside, okay? Now I'll try to blow it. Now the pressure that I will be pushing with from here will not let the ball fall until the pressure which is being exerted by the air from here. The moment the pressure that I am putting in is more than the pressure of the air here, only then the ball will fall. If I am maintaining the same pressure, the ball will not fall and it will only keep rolling over here. Look at it. See, I am blowing hard, but it's not falling. Why is it so? Because the pressure with which I am pushing is almost equal to the air pressure which is happening from here. It's coming from here, okay? So, this is called atmospheric pressure. Let's understand this concept with one more experiment. See, I have filled in this bottle with some water, okay? And I have put one paper above it, okay? So, now the water and the air which is there inside, if I tilt this bottle, will put some pressure on this paper, right? But children, you know what? For some time, this paper will not fall. It will be at its own position because the amount of pressure that this water and the air will put from inside will be almost equal to the air pressure, the atmospheric pressure which will hit this paper from outside. Now let's see. Shall I leave my hand? Oh, it's not falling. I'm holding it because otherwise things will get wet over here. So, here also the pressure which was coming from the bottom and which was holding this paper intact was the atmospheric pressure. Let's understand now. This bottle again is filled with air inside, right? This is a small ball of paper. that I am having. Now, ideally, if I push this ball or blow this ball, it should go inside, right? Let's see, because there's some air inside which is pushing it out, right? And when I am blowing it, this will push it inside, right? But it will actually not go until both the pressures are equal. No, it's not going. It's not that the ball is big. No, it's not so. See, if I push it now, it goes inside, right? That means the ball could have gone inside. But because the pressure that I am putting in from outside and the pressure which the internal air is applying on this paper, almost both of them were equal. That is why it was not going in. If I push this, see, it is going in, right? So these are few experiments, children, with which we understand the concept of pressure and also the concept of atmospheric pressure. I hope you will remember this concept. Go ahead, go home and try few experiments at your home. Don't try to do anything dangerous with the knives. Thank you so much.